All right, let's get right into it. You know, at the very heart of how the internet works, there's this fascinating corporate drama playing out. It's a story about two competing blueprints, a big corporate restructuring, and, yeah, a couple of middle managers who got fired, all for the sake of efficiency.
Welcome to Super Courseva. Unlock the secrets of the internet and master computer networking. Let's dive in.
So here's the puzzle that trips up pretty much everyone when they start studying networking. You've got two different maps for the exact same territory. One's the super detailed 7-layer atlas, and the other is a more practical 5-layer field guide. How can they both even exist? And really, which one is actually describing the internet that you're using this very second? Okay, so on one side, you have the TCP/IP model. Just think of this as the hands-on practical guide. It's what engineers actually use because, well, it shows how things really work out in the wild. And then on the other side, you've got the OSI model. This one's the official academic standard. It's the super comprehensive textbook version that you are going to find on every single certification exam. Both are important for sure, but for totally different reasons. And here's the thing, the whole conflict really isn't as complicated as it seems. The bottom 4 layers of both models, the ones that cover the physical wires, data links, network routing, and transport, they're pretty much the same. The real disagreement, the entire source of all this confusion, happens right at the top of the stack. And this right here is the perfect way to think about it. The OSI model has these 2 extra layers that the TCP/IP model just doesn't. They're like 2 middle managers in a company. They had very specific jobs, but the leaner, meaner TCP/IP corporation looked at the org chart and decided, you know what? Your roles are redundant. And boom, they were fired to streamline the whole operation. So who were these so-called middle managers? Let's meet them. We're going to investigate what exactly layers 5 and 6 of the OSI model were supposed to be doing in the first place. What did their job descriptions even say? Okay, first up is layer 5, the session layer. Its job is basically to be the network's personal secretary. It's responsible for setting up the meeting between 2 applications. It handles all the dialogue, starting the call, making sure it runs smoothly, maybe pausing and resuming it, and then ending it cleanly. It's all about managing that session, just like a great secretary manages a meeting. And right next to this secretary, we have layer 6, the presentation layer. This layer is the company's official translator. Its one job, its only job, is to take the data from the application and format it so the other computer can understand it, and then do the same thing in reverse. It's making sure everyone is speaking the same language, literally. So, what does a translator do in the world of networking? Well, it's juggling 3 big things. First, it handles encryption and decryption, scrambling a secret message with SSL or TLS so it's secure. Second, it manages compression to make files smaller, like zipping them up so they send faster. And third, it does character translation, making sure text sent in one format, like ASCII, can be understood in another, like Unicode. Pretty important stuff. Right? This is the million-dollar question. If managing sessions and translating data are so obviously crucial, why on earth would the practical TCP/IP model just get rid of the layers designed to do exactly that? It feels kind of backwards, but believe me, there's a very logical, very efficiency-driven reason behind it. So let's look at the justification. Let's make the case for why this leaner, 5-layer model ultimately won out in the real world and became the blueprint for the internet we all use today. Okay, here's the case for the prosecution. First, there were some, let's call them encapsulation issues. See, the lower layers each wrap the data in a new envelope with its own address, its own header. But the session and presentation layers, they don't really do that in the same clean way. And second, and this is the real kicker, it just came down to real-world efficiency. It turned out that the applications themselves, like your web browser, were already doing these jobs just fine on their own. And so, the verdict was in. In the TCP/IP model, the big boss, the top-level application layer, just absorbed all the responsibilities of those 2 middle managers. Your browser now handles its own session management. It handles its own encryption. There was just no need for separate departments to do what the head office was perfectly capable of doing itself. It was a corporate takeover. Which brings us to the final and most practical question of all. After all this corporate drama, which of these organizational charts do you actually need to know? The practical one or the theoretical one? This table really sums it all up beautifully. You want to use the TCP/IP model for practical, real-world stuff. It's your field guide to how the internet actually works. But you use the OSI model as the academic standard. It's that comprehensive framework that gives you a much deeper theoretical understanding, which is just invaluable when you're first learning this stuff. So here's the bottom line. For your day-to-day work, for troubleshooting, you're going to be thinking in the 5 layers of the TCP/IP model. But, and I absolutely cannot stress this enough, if you are planning to take any networking exam from CompTIA to Cisco, you must know the 7-layer OSI model inside and out. It is the language of academia, and it's the language of certification, period. So, we'll leave you with this final fact to chew on. The victory of the simpler TCP/IP model over the more rigorous OSI model, it's a classic example of a practical, good enough solution winning out over a theoretically perfect but more complex one. It really makes you wonder, where else in tech do we see that exact same pattern play out over and over again?